Hey everybody, this is just the solutions to the review, just to kind of give you a little bit of an extra chance to study, and just in case you didn't get everything from class today. So the definition of a circle is the set of all points in a plane equidistant from a fixed point. So that fixed point would be your center, and that equidistance would be your radius. Okay. Definition of a circle, again, set of all points in a plane equidistant from a fixed point. The radius is a segment from the center of the circle to a point on the circle. And the number of radii in a circle can be measured, so that there is an infinite number of radii in a circle. And the relationship between all the radii in a circle is that they are congruent. And what is true about circles whose radii are the same length? They are also congruent. So the three classifications of triangles, one of those is equilateral. And one of the properties of equilateral triangles is that all three sides are congruent. Another type of triangle is an isosceles. Let's see if I can spell that correctly. And the properties of that is that two sides are congruent. And the third type is, and this is probably the one that if you're going to get tripped up on this one, is a scalene triangle. And the properties of a scalene triangle are that no sides are congruent. So if we follow the instructions below and then answer the questions, the first directions say to plot 2 points and label them A and B. So we just put 2 points down. Remember that when you click on them, you can pick a label for them. So I have A here and I have B here. So I'm done with this one. So the next thing we're going to do is construct a circle centered at A with the radius of AB. So that just means I'm going to start at A and end at B. So we're done with that one, and then we're going to do the other direction. So we're going to start at B and go back to A. So get my circle again, go from B to A. Place a point at one intersection point of the two circles. So it doesn't matter whether I put my point here or whether I put my point down here. You can put it either place. And then we are going to label that point C. So when we click on that, we're going to label it. It turns into C. And then we're going to connect points A, B, and C. So if we use the polygon tool, that might be the best way, because then you can see it a little bit better. And we drew a triangle, and the type of triangle that we drew is an equilateral triangle. And the reason that it's equilateral is because all three sides are congruent. And the reason that we know all three sides are congruent is because AB is a radius of both circles, and AC is a radius of the circle centered at A. So it is congruent to AB. And BC is a radius of the circle centered at B. So it is congruent to AB. And so because those two segments are both congruent to AB, they are also congruent to each other, and therefore all three sides are congruent. Highlight the segments that are the same length and highlight different colors, different lengths with different colors. So one segment that we could highlight here would be this segment right here, and we can also highlight this segment right here. We know that these two are the same length, because they are the radius of the same circle. We can leave the other ones blue, so we can say the blue segments are the same length because they are the radius of the smaller circle. If we do the polygon and we do A, C, G, we should, in the last section, we said, oh, AC and AG are the same length because they are two radius from the same circle. And so because those two side lengths are congruent, this is an isosceles triangle. Segments AG and AC are both radii of the same circle, so they are congruent, and isosceles triangles have two congruent sides. Okay, on this one, we are doing ACE, so ACE. And this one is going to be a scalene triangle because none of the sides are congruent. And we know that because AE is a different radius from AC, so they are not congruent. So if we want to find the location of all the points that are equidistant from A and B, that means that we're looking for all the points that are the same distance from both of these. And if you remember the magnets that day, when we did that, what we constructed was a line straight down the middle in between these two. So if we were to draw a segment in between these 2 points and create circles at each of those points, then connect those 2 intersection points. Any point that is on this line right here is going to be the same distance to A as it is to B, and it doesn't matter where we put that point as long as it is on this line right here, and that line is called the perpendicular bisector. So anything that's on that line is going to be exactly the same distance from A as it is from B. Now, if we want to plot a point that's closer to A than it is to point B, I could put it anywhere on this side of the perpendicular bisector because anything over here is going to be closer to A than it is to B. So if I were to put this point right here, we're going to label this guy Z. Right? So Z, not by much, but he is closer to A than he is to B because he is on the left side. He's on the same side of the perpendicular bisector as A. Okay. Then we want to plot a point that's closer to B than it is to point A, and we're going to label that point Q. So if we put another point over here, I'm just going to pop this one. That looks good to me. I'm going to label that one Q, and I'm going to change the color to green so that I can kind of differentiate between those a little bit better. And the reason that that one is closer to B than it is to A is because it is on the same side of the perpendicular bisector as B. And then plot a point that is equidistant from A and B and label that point S. Well, I can pick any one of these points that I've already put down. So we'll just pick this one. I'm going to turn that one black, and we're going to label this one, and we're going to call it S. And without using the measuring tool, how do you know it is equidistant from point A and B? Because it lies on the perpendicular bisector. So if we connect points A, B, and S, so A, B, and S, without using the measuring tool, think about what kind of a triangle we drew. We drew an isosceles triangle. And without measuring, how do we know what kind of a triangle it is? We know it's isosceles because from S to A is the same length as S to B, because S is on the perpendicular bisector. So two congruent sides in a triangle means it is isosceles. Okay, construct the perpendicular bisector. That is just finding the intersection point halfway between W and X. So if we just draw a circle that has the same radius from both sides, there's our perpendicular bisector. On this one, we want to construct a line perpendicular to the existing line through point A. So remember, this is our eyeball construction. We want to center our circle, our first circle, at A because that's where we want our line to go through. And this one's the eyeball construction. So basically what we're saying, if I were to put a segment down here, and I'm going to make that segment a different color. So basically what we're saying is, just like in this last, whoops, that's not what I wanted to do. I wanted to go back a page. Just like in this one, this segment right here, we did the perpendicular bisector of it, and so we took a circle, centered it at W and went to X, and then we centered it at X and went to W. So we're doing essentially the same thing here, it's just that now we have this different segment, it's inside a circle. So now we're just going to take our circle tool and go from one side of the circle to the other and then back again. And now where those two circles intersect, we draw our line through, and there's our perpendicular line. Now it's not a perpendicular bisector because you can't bisect a line because a line has infinite length, but these two lines are perpendicular to each other. And the last one in here is construct a parallel line to the existing line through point F. So in order to create parallel lines, remember we have to construct perpendicular line first. So when we have a point that is not on the line, we just want to find 2 points on the line and use those as centers of our circle. So we're going to go from the point to the existing point that's off the line, and now you can see that those intersection points go right through F. So now we have created a perpendicular line to, we've created a perpendicular line to this line, this existing line right here. And I'm going to hide these two circles now. And I'm actually going to hide these points as well. And so now what we need to do is, in order to create a line that's parallel to this one, that line has to be perpendicular to this line. So again, this is similar to the one that we did on the previous slide, where you have to create the segment that you need to bisect. So in this case, the segment that we are going to bisect is this one right here. So I'm just going to change the color again so you can kind of see. This is the segment that we want to bisect because we want our line to be perpendicular to this line and we want it to go through point F. So we're going to grab our circle tool again, and this is our eyeball construction. And there we have, at the intersection points right here, there's our parallel line. So if you have questions, please let me know. I will also have the video for the constructions posted as well. Those would be two really good ones to look over for your review.